1 2 1 2 mic test. 1 2 mic test. Michael George, good evening. So let's wait more people to gather. So I'm gonna carry on from where we left last time. I don't know if you was on my last stream yesterday evening, and we're gonna carry on from where I left. But let's wait more people to gather. So how is everything, Michael? Carter, good evening. Aye, more people to come here, like that we can carry on from where we left. You was here last evening, Carter? Huh? Have you been here last evening when I did how the transistor work as amplifier, and we're gonna carry on now how it's doing as a switch. Yeah, thank you for being also last evening here. Stop working electronics now. It's 10 p.m. at me. Here is just 8:15. So let me know, guys, if shall I start to know, or we were waiting a bit other people. You are in Romania, so bună seara. Carter, where are you located, by the way? You must be somewhere France, Italy. I didn't have the chance to open the Discord because I was busy today at work. We have a lot of back orders that I need to fulfill them. Sweden, yeah, somewhere in that area. So, transistor to act as a switch is very, very simple. It doesn't require so many components like an amplifier, where we require also capacitors, resistors to the base, to the emitter, to the collector. It's very easy to do a switch with the transistor. So let me see which one I have here. The 337 should be the NPN still. Let me see, where is my tester to locate very easy the pins, because actually we can also look on datasheet and we understand the pins, so we can check on Google. Let me see if I can find the cable that I can put some power in this one, because long time I didn't charge it. So it's charging now. What you to present to us today? So we're gonna show how it's doing the switch. Then if James is coming in, I'm gonna show him what he had on that PCB that he was trying to fix, that was tightened together two pins of the transistor. He's saying that was an NPN, base tighted to emitter, but NPN base tighted to emitter together will not do nothing. So it's properly is a open circuit. If you tie the base to the collector and you are sure that you are not putting more than 5 volts on the collector, yeah, it will gonna act as a diode because it will gonna direct the voltage from the collector to emitter, because the base is already tighted to 5 volts and it will gonna be open at max. But if I put the base to emitter where is the negative, I'm closing the transistor, so between the collector and emitter will not be any flow of current. So that's why I wanted to show him that one. If he might join, I'm gonna do also that one, and maybe we're gonna see how also act two transistor in a stable circuit, and I'm gonna explain how the current flow during the transition, and how is important a capacitor on a circuit. Like somewhere there you can just leave it without capacitor, but in order to decide, shall I leave this circuit without capacitor or I need a capacitor in the circuit? So on a stable circuit, you're gonna see how important is a capacitor and also what is doing that capacitor on the circuit. Good evening, Oldham Electronics. Was the two transistor acting as a dialing compare? No, it was just one transistor. He was saying that was a NPN and the base was tighted together with the emitter. But if it's an NPN and the base is tighted to emitter, it's like transistor is closed and it will not flow nothing through the collector to emitter. I'm gonna understand if the base is tighted to the collector and you are not applying more than 5 volts to the collector, then I'm gonna say, yeah, it's acting as a directing current from the collector to emitter because you open the transistor at max with 5 volts. So that's why if he might join, I will gonna show him that it's impossible to be tighted to emitter because it's not doing nothing. Yeah, if the base is 0 volts to an NPN transistor, will not do nothing. If it's PNP and the emitter is and you put the base to the emitter, in that case, yeah, you are gonna open the transistor because the PNP, we need to apply negative voltage on the base. So in that case, I'm gonna say is directing the current in the opposite direction. But he was claiming that is an NPN, and he was claiming that the emitter was connected to the base. So it's impossible a transistor to work in that way. It's working only if you connect to the collector and you are making sure that on the collector there is no more than 5 volts. Because in the same times you are powering also the base, and the base will not stay more than 5 volts between base and emitter. Oh, so I think if no more people gather, I'm gonna start building up the circuit as a switch, and also I'm gonna do, as I say, the astable, and I'm gonna explain sometimes how important is a capacitor on a circuit. And you cannot just, if it's a short capacitor, like lots of people, if they find short capacitor on circuits, they remove the capacitor and leave it like that. You need to understand what that capacitor do on a circuit to understand if you can leave it without, or you must to put back the capacitor on the circuit. All right, so let's see if this is my NPN. Because my little boy last night, he played around here. So yeah, it's an NPN. And how we said, the emitter should be connected straight away to the negative. So we're gonna use the same, the blue line is the negative. How you can see over here, also show that the blue is negative. Let me try to See if this camera wants to focus. So I can see I can see there the negative is blue and the red is a positive. And we're gonna connect it straight away to the negative. We have negative to emitter, which is in here. And then to simulate a switch, we need an LED something to lights up to see that it's switching or not. So we're gonna have, we know that the positive is always the longer pin. So we're gonna have, and how I mentioned in the previous video, what is stand the NPN. So it stand N, emitter to negative, P, in the base we need to apply a positive voltage, and N on the collector, the load. If it's a polarity load, you need to attach the negative to the transistor. So in this case, our LED negative is the short one. So we're going to put the short on the collector. And the positive, we're going to use a 4.7K to positive, because we're going to still power with the 15 volts. If in case it's too high, if we need to calculate with ohm law, we can also go there. It will gonna require a 300 something ohms, but while we are here, we can start with the higher resistor and then we can go a little bit down. But as I say, if you go to the ohm law formula on dropping voltage resistor to calculate the resistor, it's from 15 volts to drop to 2.5, you are in about 400 ohms over there, something like that. So let's start with 4.7K. If it's too high, we can reduce. We have a 2.2 there. We have 1K over there. We have more resistor to play with. And then we have the positive that we're going to connect to our power supply. Let me get more wires from here. So let me get the black one for a negative. Or I can use same a blue one for the negative. And we should be all right. No, I need another wire. I can use this one. And we're gonna use a second power supply. So let me grab also the wires for the second power supply. Only just to let you know that my second power supply is not showing on the OBS because I don't have the software for it. I know that can have a software, but I need to find that TTL to USB converter in order to connect it. So the second power supply, I'm gonna put it on 4 volts there to don't go properly to the limit of the 5 volts. And we're gonna measure. We can use the multimeter, so let's measure over here to make sure there is just 4 volts. So that's negative and this is positive. So I can see here we have 3.9, so 4 volts. And on this circuit on the table, we're gonna apply 15 volts from my power supply, which it's displaying over here. And we will see how it's working as a switch. that my power supply, it decided to disconnect the USB. I just connected back. Let's see if it's working. It's telling me to update the COM port. Connect. Yeah, it's back to life. Hey James, so let me now do this this switch circuit, and then we're gonna do that one when you say that was connected the transistor 2 pins together. So let me explain. So we have two separate power supplies. So this one I cannot show it on the OBS because I don't have yet a software, and I need to look for a TTL to USB converter. So I can see here we have 4 volts. So I don't put 5 volts on the limit of the base. I just stay 1 volt less. So this one, it will gonna activate our switch to show how the transistor works as a switch. So we need another ground because we need to tie also the second power supply to the ground. My main power supply is set up same like last night with 800 milliamps and 15 volts. So let me turn it on. So I can see we have 15 volts over here. And this is the negative. And this is the positive of the main. So we can measure exactly to see that we have voltage on the rail over here, so negative and positive. So you can see we have the 15 volts over there present. And now I'm gonna apply the 5 volts to the base of the transistor, and I can see acting as a switch, lights up the LED. I remove the 5 volts from the base, I attach it, it's acting as a switch. It's very simple. And also we can use only one power supply to activate this switch using a drop voltage resistor, same from that positive to the base, and it will activate. So let me just measure how many voltage I have on the LED to make sure if that resistor need increase it or lower it. So on the LED we have 1.8, so I think can do a 4.4 4.7 kilo ohm to use from the positive. Like that, I will not use the second power supply as a switch, because I can see as soon as I touch here, the LED is lighting up, so it's opening the transistor, because the LED is connected between emitter and collector. Good thing about the tester, it is tell you which pins is to. Yeah, so mostly I'm using this tester not for accuracy of measurements of components, but has a pretty decent. So this resistor is 1K, so has a pretty decent accuracy on measuring. So you can see there 997 ohms, so has a decent, see, it's 997 ohms, so accuracy is quite good. I can't complain. But mostly I got this one for an easy pin check, pin out of the transistors, rather than open internet, go in Google, look for the pin out of that particular transistor. You just stick it in, press the button, it's telling you straight away where are the pins and which one are the pins. Yeah, also for capacitor is doing a decent job. So this capacitor in particular is 4.7 microfarads. So if I stick it here and I press the button, see, I can say there is 4 4654 nanofarad, which is 4.7 microfarads. So yeah, accuracy is quite good. It's not the precise in the world, but hey, for £6, how much costs this one? Is more than good. So yeah, so I say, let me see if I find in this bag another 4.7K. Oh, I can use also a 12K. Let's try with a 12K if it's enough. So I'm gonna put from the base of the transistor here, and I'm gonna use this wire to tie to the positive over here. And I can see I open the transistor using the same power supply, so I can remove the other power supply and using only one power supply. Tightening to the positive, and it's giving you the on transistor. So James, you saying that was an NPN transistor, sure, the one that was on that power supply that you was trying to fix? Because I'm gonna show you there. So as I say, I need to put the power supply just to 5 volts, not more than 5 volts. So I'm gonna put 4.5. So 4.5 volts on my power supply. I'm gonna turn it on. Still on 15 volts. Why don't take the 4.5? So let me try to program again. So 4. And 5. Enter. Yes. So now it's set up to 4.5. So you can see we have just 4.5 over there. So we know that this is our power rail. So positive, negative. So we have 4.5 over there. Let's make sure that we can see which one is emitter, collector, and base again. So we know the pin number 3 is emitter. So emitter, base, and collector. So we know that is emitter, base, and collector, right? And you was claiming that there was short between emitter and base. So if I short emitter and base, and then if it's an NPN, we know that the emitter needs to be tied to negative, otherwise the transistor will not work. So we're going to tie the emitter to negative. And same, I'm going to put a LED just to show you that the transistor is not doing nothing if it's tightened like that. So let me put 200 ohms over here from positive to the LED. And I can see it's not doing nothing, the transistor in that configuration. If it's tightened to the collector, the base, yes, we're gonna act as a diode and we're gonna light up the LED. So now, if I want, I can remove this transistor from here, and in the place of the transistor, I can put a diode, and you're gonna see we're gonna act the same. So let me find a diode. So a normal diode, if I have a normal rectifier diode, I can open a shop with components, guys. I have plenty of them, but only when I need something. In that moment, I'm never find what I'm looking for. This must be a normal rectifier diode. So if I don't have in this box, let me see if I have in this box. No. I think I might find one, but is solder it with another one, so I'm gonna desolder that one quick and use one of these two diodes over there and show you that if I remove the transistor and put a diode, it's doing the same things. So yeah, let me separate these two diodes. Let me turn on the power supply. Oh, the power supply, the soldering station. Let me separate these two diodes over here. And here we go. Let's take out the transistor, and instead of transistor, let's put the diode, right? So I remove the transistor from there, and I'm gonna just put the diode. And here we go. As I say, removing the diode or putting the transistor is the same thing. So that's why if it's tied to emitter, the base is, and if it's an NPN, is a closed circuit. We'll never open that circuit. So act as a diode, only that the transistor we're gonna have less drop voltage than the diode. If I look here and let me just make sure that I'm measuring millivolts. Yeah, just pay attention to the voltage drop on the diode. So we have 711 millivolts, okay, is the dropping voltage on the diode, right? And if I put a transistor, we're gonna see is the less. So that's why they use a transistor, because a transistor in that configuration has less dropping voltage. So let's measuring now. So see, you have only 636 millivolts. So that's why they use a transistor instead of a diode to have a less dropping voltage in that things. So that's why I say only Martin from PCDD Repair, because I'm pretty sure he's in his home that that device, and he can recheck again to make sure is the collector tightened with the base or the emitter. But as I say, that's what a transistor do, so there is no other option. All right, so let's have a look on that. Find on internet a stable circuit. Let's build up, and then we're gonna talk about how the current flow through and how important sometimes is a capacitor on the circuit. Because I say, lots of people, they find shorted capacitor and just they remove it without first to have a look what that capacitor actually is doing in the circuit. So let me quick look on internet for an istable circuit, and we're gonna build it up, and we're gonna talk about how that circuit working. So let me bring here my internet page, and let's look for a stable circuit. So it's a simple one, requires just two NPN transistors, like so, this one. So we're gonna use two LEDs, 47K resistors we have. Instead of 47, we can use 220 ohms over there. We're gonna power not with 9 volts, we're gonna power with less than 9 volts, maybe 8 volts, like that. And we're gonna use this circuit as a reference for us. So let's build it quick on the on the breadboard over here. So we have an NPN. Let me see the other transistor, what is already here on the table, if it's still an NPN. Yeah, is an NPN and is the 222. So let's put the same model. So let me get my box with transistor. Yeah, I like to give the right way how the people should learn, because I notice a lot of people, they are doing electronics, but they never explain like how actually the current flow through the components. And on this circuit that I'm gonna build now, it's a nice way to show you actually how the current flow when it's stopping, because it's stopping again, flowing again, stopping. So it's really nice to understand how the current flow through a circuit, because that's important to know in electronics, because you have a circuit in front of you. You need to understand, okay, I have positive, negative, but where that positive and negative is going actually to the circuit. It is stopping somewhere. Did it step carry on after? So that's why let's build up this one. So I get two 337s NPN to be the same, right? Two 337s, and I'm gonna build them over here quick. So we have the same emitter base collector, emitter base collector. So the schematic is say like that: from the collector to the positive, we need to have an LED and resistor. So let me get those LEDs to get another one, because I have one here, but we're gonna get another one. Yes. Okay, let's use the green one. And we have 220 ohm resistor. So say it's a schematic asking for 470. I'm gonna use 220. And instead of powering all the circuit with 9 volts, we're gonna power maybe 8 volts or 7 volts. So we know our NPN. And as I say on the part 1, what NPN stands for. You always start with the emitter. So N for emitter mean tied to negative. So we need to tie to the negative the emitters from both transistors, okay? So we know the negative is the blue rail over there. So emitter is this one. So from ground to the emitter, I'm connecting, because how this breadboard works. So you have these two lines that are continuously, those two lines are continuously contact from the end to every single hole, and the middle part are like that. So every single row of holes on the vertical is a line connected all the holes together, and then isolated from the next one, and so on. So you have one line with connections isolated from the second, and so on. So here are connected like that, and the power rails are connected on the horizontal. So that is the emitter over there. Let's connect also the second transistor to the emitter, to the ground, because we know our blue is ground. And then same, coming back to NPN, we have N for emitter that goes to negative. We have P from the base, which we know that we need to apply a positive voltage on the base to open the transistor. And we have again N, which stands for the collector pin, which is telling us that our load, if it's a polarity load, like the LED, they have polarity, we need to connect the negative on the collector. So the LED long pin is positive, short pin is negative. So we must make sure that the short pin, which is negative, we're going to be tied to the collector of the transistor. So I'm going to go to connect it like so. And I'm going to go also here to repeat it in the same way the other one. And now, from the positive of the LEDs, we need to bring the 220 ohms resistors to our positive rail. So we have 220 ohm resistor over here that we're gonna goes to our positive. And then we have another 220 ohm resistor that from the second LED we're gonna go tied to the positive. Then now we need the 47K resistors, if I can find them from last night. So this is one. So yellow, purple, orange. And I think the second yellow, purple, orange is just over here. And then we need the capacitor. So here we're going to play with the lots of capacitor and you're going to understand the importance of the capacitor in this circuit. Okay, so let's start with the 10 microfarads. So this is one 10 microfarad and this is a second 10 microfarad. So we need to come from the positive. So we're going to have from the positive this 47K resistor, which we're going to go there. And we're going to have same from the positive over here, the 47K resistor. Then it's telling us that between this resistor should be tied to the base of our transistors, but should be connected in this way. So the capacitor positive should go to the collector of this one. So this is my positive lead and this is the negative lead. So positive goes here and negative goes on the resistor, and negative from here the negative from the capacitor from here should go to the base of the other transistor, this one. Now we're going to replicate also here the same. So we're going to put positive on the collector of the transistor, negative on the resistor, and from there we connect the base of this transistor to join between the capacitor and the resistor over there. And now let me set up my power supply to 8 volts. So let me set up to 8 volts my power supply. Actually 7.5. That's 7.5. And let me turn it on. Actually was on, so now it's on. And we're going to apply voltage over here. So negative and positive. And have a look. Have a look what two transistors do by themselves. So one is opening the other one. As soon as this one is opening the other one, and it's trying both of them to open one each other, but they can't stay together in the same time because the capacitors are important. So now is 10 microfarads there. So let's change that 10 microfarads with 100 microfarad, and you're gonna see what's going on. So my 100 microfarads, these ones over here. So that's 100, and that's 100. We're going to switch off the power supply, and I'm going to change these capacitors. And now you're going to say how are so important these capacitors in this circuit. How are so important? Okay, we're turning on the power supply right now. And have a look now. It's slowing down the process. Yeah, you have right, Carter. Decrease the speed. Because really important here, the capacitor act as a timer. If I go to increase more, you're gonna see more slow this combination. So let's increase it now to 470 microfarads. Uh, 470 microfarads, where I have them. This is 1000. I saw one over there. And let me see if I find another one. That's 1000. $470. So let's power off the circuit and let's put 470 in, and we're gonna see more slow this process will gonna happen. So I'm turning on now. And have a look now how long one transistor is open until it's switching off and send the signal to the next one to open. Increasing the resistor, we do the same. Increasing the resistors that goes to the base, because it will gonna flow more fast the current and we're gonna charge faster the capacitor. So yeah, you have right, all them. Also playing with the resistors are doing the same. Yeah, I know. If we change also the resistance, we charging more fast the capacitor. So that's why let's go to the schematic to show you how actually how the current flow here and how it is switching off and on separate transistors. So let me open again the internet page. So practically when we apply here the current, so the positive is this on the top and the negative is in the bottom. So always the current he flow on the less resistance that he encounter, right? So the first step we're gonna go, because if the transistors are off, the current will not flow through the transistor like that. So in order to flow through here, to light up the LED, this is our LED, we need to have a current on the base. So first, this means we're gonna go the process, we're gonna start charge up these two capacitors. And then which one is charging faster than the other, because in the same times we're going to go to charge both of them, but which one is charging faster, we're going to build up enough current on the base of that transistor. So see, this is tied to this one. So let's see if this is charging. We're going to open the transistor and we're going to start the current flowing through. So as soon this this circuit is opened, the capacitors will not charge. But remember, which one is charging faster? So this one charged faster for now, in my example. On the same time, also this one had time to be charged. So we know the capacitor hold the charge, right? So as soon here the current flow, the capacitor, they start to discharge. So as soon this one is discharging, this one has still power on, and we're gonna open the second transistor, and like that the current will gonna start flowing from here. As soon the current flowing for here, same, the other capacitor had time to be charged, and this one is discharging. So that's how the current flow. So as soon one capacitor is discharging, there is no more present current on the base of that transistor, so it's closing this LED, and then it's switching off, because here there is still power on this one, which never discharged because the transistor was never conducting. As soon this transistor start conducting, it's consuming the power on this capacitor, and the other capacitor has again time to recharge in order to open other transistor, and that's why it's switching off one and another, because the current will not be able to flow and to switch off both in the same time and both in the same time off and on. So that's how the current flow through this circuit. And that's why the higher is the capacitance, more time needs to discharge the capacitor. How Mr. Oldham say that if we change the value of this resistor, we can speed up the same. We can speed up because the charging period it's longer on the 47K than a charging capacitor on, let's see, in 2K. In 2K, we're going to charge more faster, so the process we're going to still change if we are changing also value of these resistors. If we change the value of this resistance, here we need to do Ohm law in order to understand the load. So our load is the LED, so our LED is consuming maybe 20 milliamps, and we need to understand how much power is here and how much we need to drop to the resistor in order that here on the LED we're gonna have only 2.5 volts or 2.2 volts, so depend of the color of the LED depends the voltage that is applying to lights up. I know the blue LED, no, actually the white LED require the more voltage. Then next after him is the blue LED that require a bit higher voltage. Then is the green, then is the orange, and the less voltage that we need to apply is for a red one. So not all LED, depend of the color, they are powering with the same voltage. No, depend of the color is changing the voltage that you need to power an LED. So you understand so far? So let me know in the chat if you understand my explanation, how the current flowing in this circuit and what's happening with the current and the voltages. Because I explain on the way I can understand that you guys, you understand what I'm explaining. I hope you get the point. So yeah, let me know there on the chat, know if you understand what I was explaining. So I'm waiting for input. Yeah, I get it. So yeah, Carter, you are good. So that's you understand how the current flow on a circuit is this a basic way how to learn, And once you know this one properly, like you know it in your mind, as soon you see also a circuit with more transistor involved, like 3 or 4 or 5, you know the basic stuff how a single transistor work. And when you have 2 or 3 or 5, you're gonna understand, okay, if I have a PNP, I should have this kind of voltage on the collector, I should have this kind of voltage on the NPN on the collector, so opposite totally of the other transistor, and so on. Yeah, I can turn on the scope, and I'm gonna show also in the scope how the capacitor charging slowly, and then suddenly it's dropping, and then again it's charging, and then it's dropping. Yeah, we're gonna connect also the oscilloscope because I have oscilloscope, no problem. That's a more better visual to see how properly how the current goes to the capacitor. Yeah, good idea. So let me turn on the oscilloscope. Let me turn on here on my oscilloscope. So let's go with the same from yesterday. Right, and let's go back to my bench. Maybe I'm gonna zoom a bit out. Just a little bit to see my messy bench. Wires, components, everything there. All right. And good that we have two capacitors and we have two channels on the oscilloscope. We're gonna see how those working. So let me bring also the oscilloscope on the screen. So Mr. Owen is there. So where I can put the Mr. Owen, maybe in this corner down over here, and I'm gonna move a bit the circuit up there. We have a good visuality, right? And then let me just set up my oscilloscope on DC coupling because now is an AC coupling. So I need to go here, and I need to go to channel 2. Let's coupling on DC. Channel 1, let's coupling on DC, because here is DC voltage that we are going now. It's not like last evening that was AC. And that's set up. So I'm gonna send this one back. Let's set up to the ambient, the oscilloscope. So that's the ambient, all the noise that's picking up around my working bench over here. So that's all the noise that I am present over here. Somewhere around 52 kilohertz, 41 kilohertz, 27 kilohertz. Some maybe switching power supplies around over here. All right, so let's hook up one to one capacitor and the other one to the other capacitor. So this one we're gonna be hooked up over there, and we hook up this one to the second one over there. And there. But I think we can't do in the same times because we are shorting the grounds. We can't do in the same times to both of them. Maybe I can try to see against the main ground to see what's going in against the main ground. Let's see, but I can't in the same time measure both of them because they are not isolated, these two grounds, so I'm shorting out the grounds. Yeah, I know the caps are not a GND because they have the resistor to the positive. So that's why I cannot measure in the same times both of them. I could measure if with two different oscilloscopes, but both of them, what I have, are not as isolated from the ground to the USB, and still we're gonna have a short on the ground on the USB. Because those oscilloscopes that are USB and are isolated from the USB ground are quite expensive. So I bought what I was in my budget. Let me try if I connect to the ground. Let's see if we can see anything. Only if we can see anything, we can give it a try. I'm not sure if we get anything from it, but we can give it a try. Okay, let me give now an auto set to see what's happening now against the ground to measure there on the capacitors. What's happening? Yeah, you can see now the yellow is charged and the red is discharged. I can see now the yellow drop and the red go up. So let me go with another auto set. Or I'm gonna play with the time base in this one manually. Let me see it out auto what is picking up. Gonna take ages because it's fluctuating between two of them. Yes, I'm gonna cancel it. So let me do another thing. So let me disconnect them. Let me do now an auto set. But what happened here? Okay, let me turn it on again. Let me turn. All right, got some noise of 50 hertz. So let's see over here on the other pins, because actually from there is charging the capacitors. And let me try now to do here. And where? Good evening, PCD repair. Let me find on this one because usually I'm using the one that has on screen that I know to turn on the base, the knobs. This one I'm not using too much trigger. And where I should hold off nanosecond. Trying to see the time base in this ones. All right, time base voltage. That one is telling me those ones are measuring. Display horizontal. Oh, maybe here. If I go, yeah, I think from here. Let's put on 1 millisecond and how to do the zoom? No, with this one I'm moving left or right. That one is not. I don't need that one. Just a second, guys, because I say on the one that I'm daily using is the one that has on screen and has knobs, and from the knobs I know how to adjust the things. Ah, here is 2 volts per division, so let's increase this one. Let's increase this one. Because if we're increasing this one, channel 2, can be that one. Let's put also here 5 per division. Oh, go to 5. 5. Enable. 0. Ah. And if I put the channel 1, or here, because if I keep the mouse on and scrolling, it's not doing nothing. So this one is the trigger level. But how I change the division over here to see the line actually, rather than just giving auto set, because in auto set we're gonna stay longer until we're gonna catch there the signals. Volts per division to 2. Yeah, I'm gonna try to do it, but again I need to cancel. Okay, cancel, close, open again. So let me set up there volts per division to 2. So I'm going here and channel. That's okay. DC and times 10. The probes are already in times 10, both of them. Yeah. If I go here, I'm choosing what to measure, right? Here, peak detect. I think better sampling. And if I go here, time and voltage, we're gonna tell me there, this or this voltage. If I go with this one, what? Don't tell me now again it's stuck. No. If I go with this one, I just do the things on the display, adding more brightness or low, so that one doesn't have nothing to do. Here we can do Mato FFT. Here we can do, this is the zoom. like horizontal. If I go increase this one, we can see properly the movement of the lines, slowly how it's charging. So we can go to 100 milliseconds, and we can see when it's charging one and when it's discharging the other one. So I can see here the red now is charging slowly, and the yellow is fully charged. When the red is fully charged, see the yellow discharge and it start charging up. Now is the red one, and so on. What I explained it before. Now I can slow down more, like that we can see it better. So let me slow down more. So let's slow down to 500 milliseconds. I think it's too much. It's gonna take ages. Actually, we can see it better. So see, here now the yellow, which here is the green one, is fully charged and is charging slowly the red, and now the red is charged, and as soon the other capacitor is charging, is straight away is discharging the other one, because it's opening the base of the transistor, and the transistor take the power from the capacitor, and so on. See, now red now is fully charged, but as soon the other one is getting fully charged, this one is discharging automatically and start building up again. So that is the visual, like how the current goes inside of those capacitors. So you have a visual how the voltages go inside those capacitors now. How they building up the energy inside the capacitor, and then as soon they open the transistor, that's it. They die, like they discharge the charge, and then again they build up the charge, open the transistor, they discharge. And you can see switching always. Now is the yellow that drop. See? And now when reach here is the red that drop. And looks like the red is dropping less. I think that capacitor is not properly 100 microfarad. Maybe it's a bit less. But the yellow is dropping more because the value definitely has a tolerance between them. That's why the red is dropping not in the same way like the yellow. Or maybe the yellow, because the yellow is 1 volt for division. So let me put also the yellow 2 volts per division now are equal. So look where it was, what I was looking, volts per division. They were just under my eyes. They was just under my eyes when I was looking for that one, the volts per division, and I was not seeing. But look now, they're properly there. Oh. So I was looking for that one on the menu from where I can change the volts per division. And they was low under my eyes over there. Because usually, as I say, the one that I'm using more often is this one. So let me just get it over here to show you which one I'm using often. So the one I'm using often is this one that has buttons and everything, and I can control everything easy on it. This one is just a USB. The one that I'm using now is a USB oscilloscope that I can visualize everything, and I need to control everything by the mouse. And just now I saw it that it was easy just down here to adjust the divisions, because I was looking through the menu here to find out that option, volts per division, and I couldn't know. I couldn't know that just are here. Because I say, the one that I'm using daily is this one, because much easy, much fast to adjust everything from the buttons over there. I hope I'm not doing all this disaster. All right. And then I have another one, same that the USB is the picoscope, which do also nice this how is called that one. I have a lapsus now. I like the picoscope how it's doing the spectrum analyzer. So I'm using more to do more deep things. So guys, let me know that now you understand how the current flow through this circuit. Now you have also visual exactly how slowly charge. Let's also change the capacitor now under the visual here, oscilloscope, and we can see how fast is changing that one. So let me switch it off. So now we're gonna see the lines are dead, like you know when a person in hospital has that line straight continuously. The yellow has a bit of noise on because I think I need to buy a new probes because has a bit. If I twist a bit there where it's connected, it's building up more noise. So yeah, let's change the capacitor. Let's put less capacitance over here, and let's see that one how fast it's changing. So let's put the 4.7. Let's see the 4.7 how fast it's charging. Let's see how fast it's charging the 4.7. It died. And then let's hook up this one here. Let's hook up this one here. And now let's turn on the power supply. On. And have a look how fast now everything is charging and discharging. See? It's more fast. So now if I want to go there, I need to slow down more here, maybe this 1 to 5 seconds to see the visual. Actually it's too fast. I think I need now to increase. I need to increase the speed. So let's reduce to what is the 1 microsecond. I think 1 microsecond is 2, maybe 100 microseconds. 1 millisecond. What is doing 1 millisecond? Still we cannot see nothing. No. So in which we was in 500 milliseconds? Yeah, it was in 500 milliseconds that we can see how fast is charging and discharging the capacitors. How you can see also the LEDs to 100 milliseconds. So let me put 100 milliseconds. 100 milliseconds. Yeah, we can see it a bit better here. But still, like running so fast, also in 10. I wanted to see it like really slowly, but I don't know the time base too much, the time base of the charging and discharging the capacitor. Fifty milliseconds. 50 milliseconds is just, we can see a little bit of movement only. So 1 second, what's happening if I put 1 second? Yeah, because the period, now I should do the other, you have to capture it. Yeah, because it's quite fast, the 4.7 microfarads, it's too fast. So that's why we have that blink it so much fast. All right, so Guys, what else you like to see? Because now we see how they work, how the current flow into some circuits. Again, I have problem with the probes over there. And yeah, let me know what we were gonna do next. We have like an hour that I can no, another, it's 9:30, so another 15 minutes to stay here. Huh? What else we were gonna do in 15 minutes? We're gonna just have a chat, or we're gonna try something else? So, James, are you still here around? Have you seen the story with the transistor, if it's NPN tied to the emitter or to the collector? So now if you have time, have a look on that circuit, really where it's connected and which type is the transistor. Because I say, if it's tied to emitter, it's like a dead circuit. But if it's tied to collector, yeah, act as a diode with the lower drop voltage. All right, so tomorrow evening, actually, let me show you what we're gonna do tomorrow evening before we closing. That's what we're gonna do, and then I'm gonna close. So, right, let me switch off my oscilloscope because we saw how the current flow to that capacitors. Let me switch off the power supply, remove this from here. Clean up a bit the desk because I'm gonna bring the box with all the parts that we're gonna do tomorrow. So tomorrow we're gonna have some action. I'm gonna work on the Krell. We need to rebuild the power supply because we have a problem. So this one is a 2NN, so stay there. The other things, they can go in this bag and keep them aside for other educational. Hi guys, I'm late again. Okay. Good evening, laptop fix. Yeah, usually my time to can stream is that, and tonight is more quiet because my little boy didn't have any nap during the day. I give him dinner, I let him run a bit around the house a bit to start digesting the food. I brush his teeth and I put him sleep, and as soon as I put him in the bed, he fall asleep straight away, so he's sleeping right now. Because tomorrow is going to nursery. He's feeling much better than 2 days ago when he had fever 39. I'm at work, sorry man. It's alright, everybody needs to work, also me, every day. Wake up 5:10 a.m., 5 o'clock. Usually I always wake up more early than the alarm goes off. I have alarm always at 5:10, but always I open my eyes at 5. Okay, let's put this one aside because we're gonna carry on more educative things because there is more things to learn about transistors. And then we need to pass to the next transistor, which are the FETs or the MOSFETs. And I think I have one IGBT here around. And we're gonna see also the IGBJT, how is working that transistor. Because I say that was a combination between MOSFET and BJT. And it's really interesting how those transistors work. Because you need to be careful with those ones. Because maybe you think that is acting as a BJT, but actually is acting as a MOSFET, but then if it's acting as a MOSFET, you're gonna think, okay, it should be controlled as a MOSFET. No, you need to control it as a BJT. So those one, yeah, are a bit more special transistors. I think I have one around here. But let me show you what we're gonna do tomorrow. And tomorrow I can stay longer, maybe until 11 o'clock, something like that, before my wife, she's getting home. So here is the box with all the parts that goes into the Krell, a part of this and this. So those don't take into consideration. So we have the isolator for the power transistors, because we need to add this nice power transistor. Let me zoom a bit out, sorry guys. Maximum I can do. That's that. So we're gonna have this transistor to change on one channel, because one channel are MGE like these ones, and the other channel are old ones that the Krell had on the factory. So we need to take the one that Krell had in the factory and install this one, because the one that Krell use it on the factory, you cannot find it on the market. Is call it A and double A. The PNP is double A and NPN is A, so you don't know which transistor are those ones. So we need to install these four. And another 4 over here, because there is 4 PNP and 4 NPNs. So we're gonna install these ones. So that's why we have fresh mica isolator, fresh washer isolators. So we need to change those ones. And then we're gonna build the power supply, because it's a dual rail, and against the ground I have minus 55 and positive 65, so it's 10 volts difference between them, which is not good. So we need to change the bridge rectifiers. So this one, they are gonna go in. These are the bridge rectifiers. They are quite small. Should be also bigger ones if I could find them, but they are very expensive, the bigger ones. So we have those one to install, and we need to replenish some Coca-Cola cans over here, 4 pieces. So we go with good Nichicon capacitors, 80 volts, 47,000 microfarads. So they're gonna go 2 per channel and another 2 for the other channel. So who wants a Coca-Cola? I have 4 blue ones. So we're gonna replenish those ones. The bridge rectifier. We're gonna test the power supply to be balanced. How much we have in the right channel to be also in the on the left channel, and the negative voltage to be equal to the positive voltage. And then if we still have time, I need to change also some capacitors on the speaker protection circuit. So we have here some fresh capacitors because they are dry, those ones there. And it should be good like that for tomorrow. So tomorrow evening we're gonna do live stream rebuilding the power supply of this Krell. So we have all the parts here ready to go. and we're gonna build it up. Because during the week, as I say, I can't stay too long because every day I wake up at 5 a.m. So last week when I stayed long, almost until 11 o'clock, I sleep less and I was so tired when I went to work. So please drop me a message who is still here watching me, and then I'm gonna say good night to every one of you. So yeah, like, who is there? You can start telling me good night, and I'm gonna say back to you good night. At least I know how many people are stayed until the end. Huh? So let's see. I'm curious how many people they stay until the end. I'm really curious. Can you drop off all of you a good night there? So we have Laptop Pigs, good night. PCCD Repair, see you later. Then I saw also James before, maybe he already left. I can go through the chat to have a look. Was there, he didn't say good night or something, leaving, he said good explanation, so maybe still here. So then we have the Oldham Electronics Repair. If you are still here, I can drop a good night, will be nice. Then we had Cartor. I don't know if he's still here until the end. It's only a USB oscilloscope. Yeah, the one that I used at Cartor was just a USB. Because the one that I show you, the one that has a main display, also that one is connecting to the computer, but it's very slow. It's very slow to transmit to send me the data to what is showing me on his main display to the computer. It's quite slow, that one. I have also the software for him, like for the other one to connect it to. Let me open to show you how it is. So I need to go here because the software for the other one, the main that I use that has a main display, looks like this one. So let me see how to show you. I think I need to do a new image capture. So let me try to do window capture, yeah. And I'm gonna just not name it because I'm gonna delete it because I tried to use that one as a main one also for the computer. I slow. I don't know why. I think it's this one. See, this one is different. This one is the software for the main one, the one that I show you. You see it, not the one that has his own display. But it's so slow to send me the data from what I saw already on his own display to send me on the computer. So that's why I'm not using it. Did you get the hobnobs in? What do you mean that one? Hobnobs in? Oh, taking your tablets. Oh, sorry. It's can you change the baud rates? I look at there. So this is the communication. This is the port setting. Is not connected yet because I don't have plugged the USB on it. Only from here I can adjust few things. See, it's also recognizing the other because the other one is same O1, and that one is already connected to the computer and is recognizing also that one. but it's not working too much well with that one. So here you can connect the device. See, he detect me the one that is already connected, the one that is only USB one, because that one is not connected. But maybe I'm gonna connect it for tomorrow, and maybe together, if you have time to watch me also tomorrow, maybe we can see together if we can make it to work nicely. Because I say I tried all the things that I could. It still send me data very slow. Yeah, I don't know what is the hobnobs. Yeah, so this is the software for the other one. So maybe if tomorrow we have a little time, I'm gonna hook it up with the USB, and we're gonna try to see how we can make it work better. Because I say I prefer to use that one, because from the knobs it's more fast to adjust everything like 10 base, volts per division, and so things, than going with the mouse checking the things. So we're gonna see tomorrow on that one. And then the picoscope is this one, which it's a really good one. I like it, the picoscope. So let me bring it here on the screen, the picoscope. So where is the pico? Pico, it's here. And hi pico, why you don't show the picoscope? I guess it's this one. So this one is the picoscope, which is really more accurate than the oven. I can do also, as I say, I can do this spectrum analyzer here. If I do the spectrum analyzer, I can do spectrum analyzer also. Yeah, has more things this Pico to offer. And the response time is so fast that I can pick up every single movement of the voltage of the currents around the circuit with the picoscope. This one. It's really fast, fast, fast. I really like it. All right, so that has been said. We're gonna see more things on the next days, because I say tomorrow evening we're gonna have action, soldering, rebuilding up the power supply, and also finding also there the fault, because something is problem there, is a fault. The voltage should be equal for the negative and the positive, around 65 volts positive and 65 volts negative against the ground. But I say I'm measuring only 55 volts negative and 65 volts in positive, so 10 volts difference, it's something wrong. So for now I can blame the capacitor, maybe are old and they are not anymore matched in pair to hold the same voltage and the same capacity. Or might can be the bridge rectifier that is a bit shorted on the side that is giving me the negative voltage and is dropping too much, it's losing too much voltage to the junction. So we're going to discover tomorrow. I say I can blame these two, because the voltage that comes straight away from the toroidal, it's equal. So if the voltage from the toroidal is equal, I should have the equal voltage also after the rectifier. Is the GND offset? Yeah, it's the ground, negative and positive voltage, but the voltage straight away from the toroidal, it's equal. I have equal voltage, so I cannot blame the transformer, because otherwise, if it was the voltage to be low straight away from the toroidal, I'm gonna blame the toroidal. Maybe some turns on the transformer, they get shorted and doesn't do anymore that voltage. But no, the AC voltage is equal, is balanced. Only when it's going to DC voltage is all unbalanced. I'm gonna try tomorrow to fit it on the table, how much I will gonna be, because it's quite a huge, it's a monster. I'm gonna try to see how I can fit it on the table, and we're gonna work on it, and we're gonna discover tomorrow things. Otherwise, I might bring the table, which you see it there. I'm gonna attach it next to my desk. I'm gonna adjust my camera overhead camera in order to film a bit in an angle, and we work like that. We're gonna find a solution. If it's not enough space on my table, because I need to work. I received the components, original parts from Mouser, and the transistor from Farnell. I think he got the transistor from Farming because he get a better offer there than the Mouser. Mouser maybe they was more expensive on the transistors. Anyway, we're gonna work on that one tomorrow. Because I would like to stay longer on chatting and showing more things that well, sharing my knowledge, and if someone learn from my skills and my knowledge, I'm really happy because what I know every day we are learning. Also me, still I'm learning things. Like as I say, the first time what I discovered with this Krell, to encounter a diode that doesn't measure as a diode, measure both directions. So when I measure it first time, I say, it's a diode. The diode measure only in one direction. Why this one measure in both directions like a normal resistor? Then I did a deep research about that diode, and apparently is a diode that regulates the current to 3.3 milliamps, and doesn't matter there is spikes on the voltage up and down, that diode will gonna keep a stable current of 3.3 milliamps. And then I read, so how that diode you measure to understand if it's okay or if it's not okay? Because if I measure as a resistor in both direction, in the data sheet is not telling me how many resistance I should have there, because that diode is changing the resistance inside, depends on the spike of the voltage and current that comes in the front of it, in order that after it to keep only a stable 3.3 milliamps, like a constant current. And then I read that you need to put it on the breadboard, put a load underneath, attach the power supply on the front and play with the voltage up and down, and you measure the current after it to make sure that the current will not change. So you cannot measure like a simple multimeter measure that one. You actually need to build up a small circuit on a breadboard and measure that diode. Yeah, it's like a current limiter, but it's just a simple diode. Just a simple diode. Let me bring it to show you which one is. Let me put overhead. Let me show you which one is. I'm gonna zoom a bit in because I can't bring the microscope. I need to go the microscope 30 centimeters from it up. So I'm gonna try to zoom in as much as I could. And we're gonna end up the stream showing you this diode that which I discovered now, that measuring in both directions. Let me zoom as much as I can on that diode to show you. Sometimes when I zoom too much in, my camera go a bit funny, forget to focus. So let's see if, so see, this diode is the one. See, has a line on it showing that the diode has a polarity, like the one next to it. But have a look. So let me put on diode mode. So have a look on the white multimeter, not the black one, the white screen multimeter. So we are measuring in diode mode. See, this is a diode. See, measuring the junction of the diode, the 600 millivolts. And if I swap, it's not measuring anymore, nothing. Actually, it's measuring a capacitor there that is charging and discharging. But actually, the junction is that one. That one, what you measure there. That is the junction of the diode, the 600 millivolts drop. And if I measure this one, have a look this one. Both direction, it will gonna give me the same. So 561, 492. So it's too low to show me that is a diode. And I don't know if this one I can do also in the continuity mode, that measurement. Let me have a look. Not sure. So in continuity, no. Let me see in the resistance what it's doing. If in the resistance is, I can do this measurement. I have a reading over there. And see, like that I don't have. So now in the resistance you can understand better. See, on this direction I'm not getting any reading through the diode because it's not conducting. And if I swap this one, we're gonna conduct and we're gonna give me a reading. So you're gonna see now the junction of the diode is activated and I can have a reading between inside the junction. And this one, look, we're gonna act in the same. Doesn't matter which side. So 599, you can see there ohms. And again, so black in this side, so 599, right? Now let's put the black on the other side. And we're gonna have the same, 599. Yeah, not too much far from 599. So that's my diode that, even if I take it out from the circuit, still measuring both direction. Because I take it out from the circuit there and I desolder it and I measure it separated, just not in the circuit, measuring same direction. So that's what I also discovered recently. And as soon as I meet that diode, straight away I go to learn about it, because that's what you need to do when you encounter a new component, to understand what he's doing and how he's working on the circuit. You need to learn about it, because if you don't learn about it, you'll never know why mic can fail. That diode was the reason that mic can fail, or something like that. At least if you know about the diode, you know what it's doing, you're gonna understand also what can kill that diode, in which situation can burn out or can short out or whatever can die. Look, we have someone else tonight as a guest, because my little boy as a guest tonight, so he fall asleep. I checked before. Now we have someone else as a guest tonight. Come say hi to my viewers. Come say hi. We have another guest tonight. I go. Go. All right, guys. So we're gonna see tomorrow, working on the Creel, building up the power supply to make sure that it's there okay, and then I can install this amplifier inside the chassis, because that's why I keep them under the table over here, because pointless to install them, then take them out, work on the power supply, and so on. So just the one. Yeah, because my little boy is sleeping, he fall asleep. Okay, guys, thank you so much for watching me. I hope that you get some good from my videos. I hope that you also enlarge your knowledge about electronics, about the components, how they work in the circuit, and also we learn how also the current flow through a circuit. We learn also in some places how important is the capacitor to give us a time base of pulses. So it's not like you see a shorted capacitor, you take it out and can stay without capacitor. First, you need to understand what that capacitor does. Because if it does something that create an impulse, like on this one, what you saw it on my table today, that impulse, some other IC may be reading that impulse, and if it's not anymore correct, we're gonna say, oh, something in front of me is not giving me the right signal that I need to understand what I do next. And this has been said. I'm gonna say a good evening to each of you, and see you tomorrow evening. Bye bye, guys.